Hello and welcome to lesson 5G. I can name the properties of a trapezoid, an isosceles triangle. Let's add and a kite. Ooh, we missed part of the title. And kites. And kites, the last of our quadrilaterals. Well, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So when we mark our trapezoid, the only thing you need is one pair of parallel sides, as you can see here. A quadrilateral has two pairs of base angles. So my base angles are here, and then here and here are my base angles. Let's mark these over here, base angles. Two legs. My legs are these non-parallel sides, right? A leg and a leg. And two bases. The bases are the parallel sides. So this guy here is a base, and this guy here is a base. The two pairs of, there are two pairs of supplementary angles. And those angles are actually located right here and right here. Your supplementary angles, angle P plus angle Q will add to 180, and angle R plus angle S will add to 180, because when you look at them, they're actually same side interior angles with the bases acting as your boundary lines. So we learned, you actually saw this question in your practices in Unit 2. But if you look at the angles that touch a leg, those two angles will always be supplementary. There's another important segment in this trapezoid, and that segment is called the mid-segment. Now, we've run into mid-segments before in triangles, and in a trapezoid, it means the exact same thing. A mid-segment is when you take the midpoint of each of your legs, your midpoint, right? And then you connect the midpoints. This here is your mid-segment. Mid-segment. And just like in a triangle, the mid-segment is going to be parallel to both of your bases, and its length is going to be half the sum of the length of the bases. So your mid-segment is actually going to equal base 1 plus base 2 divided by 2. We could also say that it is the average of the bases, because when you add them together and you divide by 2, it's the average. There's two pieces. So moving right along, we have a special kind of trapezoid, and that is an isosceles trapezoid. And an isosceles, can we make this, I don't know how this, isosceles trapezoid is a trapezoid with congruent legs. So everything about a trapezoid, it still is a mid-segment, you still have parallel sides, you still have supplementary angles, but now your legs are congruent. And there's some special properties when that happens. An isosceles trapezoid is a special type of trapezoid, so it inherits all of a trapezoid's properties. Each pair of base angles are now also congruent. So angle P and angle S will be congruent, and angle Q and angle R will be congruent. Now again, P and Q are still supplementary, and R and S are still supplementary, but now you have some congruency relationships too. The diagonals of an isosceles trapezoid are also congruent. So when I draw in my diagonal, PR is going to be congruent to QS. Now they don't bisect each other, because if you look, we're not breaking this into a nice nice congruent triangles. They don't bisect each other, but they are congruent. So that's an isosceles trapezoid. Next, we come to trapeziums, and this is only a US definition. If you say trapezium to somebody in the UK, they will think you are nuts, or they'll think that you're talking about trapezoids. But a trapezium is a quadrilateral with no parallel sides, none whatsoever. And then we have a special kind of quadrilateral. A kite is a quadrilateral, or a special kind of trapezium. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. So consecutive congruent sides. And what that means is that your opposite sides absolutely cannot be congruent. Your kite is a special kind of trapezium because there will be no parallel sides. The diagonals of a kite are actually perpendicular to each other. We'll mark all this here in a second. Perpendicular. And one and only one will be one diagonal will be bisected by the other. And based on 3 and 4, we can say that one diagonal is the perpendicular bisector of the other. And one and only one pair of angles will be congruent. And one and only one pair of angles will be bisected. It'll be the other pair that's bisected, which we're going to add right here. So one and only one pair of angles will be bisected by a diagonal. So let's mark this up then. First things first is that our consecutive sides are congruent. Consecutive, of course, means in a row. So WZ and WX will be congruent, and XY and ZY will be congruent. Okay. It's a trapezium because none of my sides are parallel. My diagonals, however, are perpendicular, like that. Okay. One of my diagonals bisects the other. So WY is bisecting XZ, and you can see how it's easily the one being bisected. So I'm going to put 3 little bitty ticks here. And then one and only one pair of angles will be congruent. Well, this angle here, angle WXY, will be congruent to angle WZY. But the other angles, XWZ and XYZ, they're the ones that get bisected by this diagonal. Keep in mind that they do not bisect evenly. So like this guy will bisect here, but as these angles down here are a different measure, they're bisected but not equal to their green angle counterparts above. So, and I believe we've now marked this thing up completely. There are a lot of cool things going on in a kite. So, segment WY is the perpendicular bisector of segment XZ, and angle WXY is congruent to angle WZY. That's my blue angle, right? All right, guys, this brings us to the end of lesson 5G. Please take a minute to look over your notes and try the MML assignment. Thank you very much.